Hello friends, today we are discussing about units. Hope you all are remembering in the last session we discussed about physical quantities. Physical quantities are some physical properties which are measurable. Usually when you are measuring a physical quantity, you are comparing with a standard reference. An unknown quantity is compared with a standard reference. Such a standard reference is known as unit. You people are familiar with such a units. We used many units for the measurement. Remember, for the length measurement, you may be used centimeter and meter. For the mass measurement, gram and kilogram. You are familiar with such a units. Today, we are discussing about different types of unit and the unit system. Let us see, this units can be divided into fundamental units and derived units. Fundamental units means for the measurement of fundamental physical quantity, we are using some units. Such units are known as fundamental units. Remember, what are fundamental physical quantity? Fundamental physical quantities are independent of all other physical quantity. Example, length, mass, time, electric current, etc. are fundamental physical quantity. For the measurement of such a fundamental physical quantity, we are using fundamental units. What are the example? For the length measurement, you are using meter. So meter is one of the example for such a fundamental unit. Meter, fundamental unit. Centimeter, you can use centimeter also. And see, for the measurement of mass, we are using kilogram. So kilogram is another fundamental unit. Mass, kilogram. For the measurement of time, we are using second. Second is another fundamental physical quantity. So the fundamental units are units measurement for the fundamental physical quantity. Example, mass is measured in kilogram and time is measured in second and the length is measured in meter. So meter, kilogram, seconds are some of the fundamental units. Whereas derived units are units for the measurement of derived physical quantity. Hope you all remembering that derived physical quantity, one of the example is speed is a derived physical quantity. What is speed? Speed is equal to distance by time. Speed is equal to distance by time. So distance is length, length by time. So what is the unit of distance is, you can write as it's meter, and what is the unit of time is second. So now we are getting the unit of speed is meter by second, can read as meter per second. So this unit is deduced from meter and second, both are fundamental units. So we calling this meter per second as a derived unit, which is deduced or derived from meter and second. So it is a derived unit. So derived unit are the unit which using for the measurement of derived physical quantity or which is deduced from our fundamental quantities. So that about derived units. Example, meter per second square, kilogram, meter per second. These are some of the example for derived units. Hope you know that we have a number of physical quantities. When you are measuring a physical quantity, usually after measurement, suppose you have measured the mass of an object. You are getting the mass of an object is 5 kilogram. So every measurement having two parts. After the measurement, we are getting a number and a unit. When you are measuring a physical quantity, after the measurement, we are getting a number and a unit. We have a plenty of such a physical quantity, but for the measurement of all this physical quantity, we have few number of units, because all physical quantities are interrelated. Example, we already seen speed is a physical quantity which are deduced from length and time. Such a way, all physical quantities are interrelated. So, for the measurement of all this physical quantity, we are using this fundamental units and derived units. Such a complete set of fundamental and derived units for measurement of all physical quantities are known as a system of unit. A system of unit is a complete set of fundamental and derived units. We have such a number of system of unit which was extensively used by scientists in different countries for the experimental purpose. See some of the physical unit system which is used for the measurements are: one is a CGS system. C stands for centimeter. For the length measurement in such a system, C, centimeter. Centimeter is used. G for gram. For the measurement of mass, gram is used in such a system. S for the measurement of time, second is used. CGS system. Another system, FPS system. F for foot. For the length measurement, foot is used. For the mass measurement, pound is used. For the time measurement, second is used in that system. And in MKS system, it's another system. For the measurement of mass, kilogram is used. For the measurement of length, meter is used. For the measurement of time, second is used. MKS system. So, but nowadays, commonly in every world, in every countries, a single unit system is following. That single unit system, which is using everywhere in all purpose, not only in the experimental purpose, we are using it in the industrial purpose, technical purpose. We are using the SI unit system nowadays. It was developed by the General Conference of Mass and Measurements conducted in Germany in 1971. All the units and their symbols are developed by the General Conference of Mass and Measurements in 1971. Then onwards, everywhere we are using the SI system for the measurement of all physical quantities. In SI system, we have 7 fundamental units. You know that in SI system there are 7 fundamental units. That is, for the measurement of length in that system, meter is used. For the measurement of length, meter is using, and symbol for meter is small letter m. For the measurement of mass in SI system, kilogram is using, and symbol for kilogram is kg. For the measurement of time, we are using second in SI system. Symbol for second is small letter s. For measurement of electric current, ampere is using, you know, it is a name of scientist starting with a small letter only, ampere, and symbol for ampere is capital A. For measurement of temperature in SI system, we are using Kelvin. Capital K is the symbol. And amount of substance, using mole, and MOL is the symbol. for the measurement of luminous intensity, maybe a new word for you, is a measurement of intensity of radiation or intensity of any radiations, and its unit is candela and symbol is CD. We have 7 fundamental physical quantity in physics, and for the measurement of this 7 fundamental physical quantity we have 7 fundamental units. What are they? Meter, kilogram, second, ampere, Kelvin, mole and candela. Along with the 7 fundamental units, we have 2 more units, supplementary units. They are for the measurement of angle, plane angle. If you are drawing an angle in this plane, the angle is measured in radian. Radian. The symbol for radian is RAD. Angle is measured in radian. Symbol is RAD. Like as we have an angle in 3-dimensional space. If the angle is in 3-dimensional, we measured in another unit known as steradian, and symbol for steradian is SR. These are only the fundamental units in SI system. By using this 7 plus 2 fundamental units, we can deduce all other derived units. In SI system, we have derived units 2. For the measurement of all this derived physical quantity, we can form all these derived units by using these fundamental units. Thank you.